Dear students, welcome back. Today we are going to start a new topic. It's from geometry and the topic is triangles. And in this topic we'll study about congruency of triangles. Congruency of triangles. Okay. Now, before starting the topic congruency of triangles, first of all, let me explain what are the congruent figures. Now, what is the meaning of congruency and what is the difference between congruency and similarity? Now, all of you pay attention. Suppose there is a square whose length of each side is 2 centimeter, and suppose there is another square and the length of each side of that square is 5 centimeter. Now you can see both are squares, so they have the same shape but the sizes are different. This square is a smaller one because each side is 2 centimeter, and that square is the bigger one because each side is 5 centimeter. So the shapes are same but sizes are different, so they are similar figures. These two figures are similar figures because they have same shape but different sizes. Now suppose there are two squares, length of each side of the first square is 3 centimeter, and there is another square and length of each side is 3 centimeter once again in that square also. Now you can see as both are squares, so they have the same shape and the sizes are also same because the length of the sides are same. So these two figures, they are called congruent figures. They have same shape, same sizes, so they are called congruent figures. So always remember, if two figures are congruent, then they are same in all aspects. Clear? So when the shapes are same and the sizes are also same, then the figures are called congruent figures. So they are congruent figures, same shape and size. Okay, so I hope it is clear to you. If two figures have same shape but different sizes, then they are similar figures, and if two figures have same shape and same sizes, then they are called congruent figures. Similar figures and congruent figures. Now I'll tell you about congruency of triangles. Suppose there are two triangles ABC and PQR. There are two triangles ABC and PQR, and it seems that they are congruent. It seems that they are identical, but we have to see what are the factors given in these two triangles. Now it is given that side AB is equal to side PQ. It is given AB is equal to PQ. Then it is given that BC is equal to QR, means the corresponding sides are equal. BC is equal to QR and AC is equal to PR. AC is equal to PR. So see, in these two triangles, it is given that AB is equal to PQ, BC is equal to QR, and AC is equal to PR. Means all the three corresponding sides are equal. Then we can say that these two triangles are congruent. So we represent it like this: triangle ABC is congruent to, this is the sign for congruency, triangle ABC is congruent to triangle PQR. Always remember, while writing the congruency, you have to maintain the order of the vertices. Means if you are taking ABC, it should be PQR. You cannot write triangle ABC is congruent to triangle QRP, then it will be wrong. Okay, so triangle ABC is congruent to triangle PQR. ABC is congruent to PQR, and when all the three corresponding sides are given equal, then we say it is side side side. Side side side, and in short we call it SSS congruency. So this is called SSS congruency. These are called the criteria for the congruency. So this is one of the criteria for congruency of two triangles. Side 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 means SSS. Always remember, if three corresponding sides, corresponding means AB has to be equal to PQ, not AB equal to QR. AB has to be equal to PQ, BC equal to QR, and AC is equal to PR. If three corresponding sides are equal, then the triangles are called congruent. Excuse me. Now, I told you when two figures are congruent, then all the corresponding parts, all the corresponding parts of the two figures are same. That means these two triangles are congruent, it is clear. So that means angle A will be equal to angle P, angle B is equal to angle Q, and angle C is equal to angle I. Because in a triangle we have six things: three sides and three angles. Three sides, corresponding sides are given equal, so three corresponding angles will also be equal. So we can say angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R, by CPCT. Now what is the full form of CPCT? The full form of CPCT is corresponding parts of congruent triangles. The full form of CPCT is corresponding parts of congruent triangle. So whenever you write the corresponding parts equal, you have to write the reason by CPCT. Clear? Now, this I told you this is one of the criteria. Now the second criteria. Suppose again they have given us two triangles, ABC and PQR. Again, as I told you earlier, these two triangles, they seem to be congruent, but we have to look for the information they are given about these two triangles. Now it is given that AB is equal to PQ, given AB is equal to PQ, then BC is equal to QR, BC is equal to QR. They have given only two corresponding sides equal, means AB is equal to PQ and BC is equal to QR. The third side, it's not given that they are equal, that the third corresponding side is also equal. So we cannot say that these two triangles are congruent by SSS congruency, because I told you in SSS congruency all the three corresponding sides should be equal, but here only two corresponding sides they are given equal. Now what you do? Now they have given this angle B is equal to angle Q. It is given that angle B is equal to angle Q. Means they have given two corresponding sides equal, and the included angle, means the angle between those two sides, the included angle, it is also given equal. Angle B is equal to angle Q. then once again we can say that these two triangles are congruent. So in the first one, all the three sides are given equal, and in the second one, two sides and the included angle are given equal. So again you can say that triangle ABC is congruent to triangle PQR, maintain the order of the vertices, and now this is called side angle side criteria. Side angle side criteria, in short we write it as SAS. In short we write SAS. Clear? And once it is given once it is given that these two triangles are congruent, now we can say that AC is equal to PR, means the third side it is also equal. Angle A is equal to angle P and angle C is equal to angle R. Means the remaining corresponding parts are also equal. AC is equal to PR, angle A is equal to angle P and angle C is equal to angle R. Again you will write the reason by CPCT, and all of you know what is the meaning of CPCT. Now in this criteria, always remember that the angle has to be the included angle. Means they have given two sides, two corresponding sides equal. Then the angle should be the included angle. Means that angle should be the angle between those two sides. If they have given that AB is equal to PQ and BC is equal to QR, and then they have given angle C is equal to angle R, then that information is not sufficient to say that these two triangles are congruent. For two triangles to be congruent by SAS congruency, the angle has to be the included angle, means it should be between those two sides. In other words, it should be always SAS, it cannot be SSA or it cannot be ASS. Clear? It has to be SAS, the angle in between. Clear? Now the third criteria. Now in the third criteria, they have again given two triangles. ABC and PQR, but they have not given, they have, although it seems that the two triangles are congruent, but we have to check for the informations given. So they have given that BC is equal to QR. Only one corresponding side in the two triangles are given equal. Given BC is equal to QR. It is given that BC is equal to QR. But they have given that angle B is equal to angle Q and angle C is equal to angle R. Means two corresponding angles are also given equal and one corresponding side. So angle B is equal to angle Q and angle C is equal to angle R. So if these informations are given, so once again we can say that triangle ABC is congruent to triangle PQR, and now it is called angle side angle. Angle side angle. In short, we call it ASA, angle side angle congruency. So triangle ABC is congruent to triangle PQR. See, the orders are same of the vertices, and it is called angle side angle or ASA congruency. And once it is proved or it is given that the two triangles are congruent, now we can say angle A is equal to angle P, the third angle, AB is equal to PQ, another corresponding side, and AC is equal to PR, and that is also by CPCT. That is corresponding parts of congruent triangles. Now there is a very interesting thing about these two, about this criteria of congruency. As you know, in a triangle, the sum of three angles is equal to 180 by angle sum property of a triangle. So if any two angles are given equal in two triangles, the third angle has to be equal. Automatically, when this angle is given equal to this angle and this angle is given equal to this angle, then automatically these two angles are equal because the sum has to be 180. So in two angles on one side, it can be AAS also, or it can be SAA also. Means in two side and one angle, that is SAS congruency, that angle has to be the included angle. So it has to be always SAS. But here it is not necessary. Means it can be ASA, or it can be AAS, or it can be SAA also. Anything. Clear? So if any two corresponding angles are given equal and one corresponding side given equal, then we can easily say that these two triangles are congruent. And now the last one. And now the fourth one or the last one is, suppose there are two triangles ABC, PQR. This angle is given 90 in both the triangles. Now AB is given equal to PQ and AC is given equal to PR. Given angle B is equal to angle Q is equal to 90 degree, AB is equal to PQ and AC is equal to PR. Now see, here two corresponding sides and one angle, they are given equal. So can we say that these two triangles are congruent? The answer is no, because when two sides and one angle are given equal, then I told you it has to be the included angle, then only we can say it is by SAS. But here they have given these two corresponding sides equal, but the angle which is equal is not the included angle, the other angle. So we cannot say that these two triangles are congruent by SAS, but actually as these angles are 90, so we can say that triangle ABC is congruent to triangle PQR, and now this is called right hypotenuse side. Means right angle is there in both the triangles, hypotenuse equal and another side equal. So right hypotenuse side. Right hypotenuse side, in short we call it RHS congruency. We call it RHS congruency, right hypotenuse side. But it is true only when this angle B and Q are 90 degree, not for any other angle. If this angle is 80 and that is also 80, we cannot say that these two triangles are congruent by SAS congruency. It cannot be RHS obviously, because when no right angle is there. So these two triangles are congruent only if these angles are 90 degree. Clear? So this is the fourth one, called the RHS congruency. And once it is proved that they are congruent, we can say that BC is equal to QR, angle A is equal to angle P, and angle C is equal to angle R by CPCT. Okay, these are the four criteria for congruency of triangles, and now we will use these criteria to solve the questions based on congruency of triangles. ACBD is a quadrilateral. ACBD is a quadrilateral. Given AC is equal to AD. It is given that AC is equal to AD, and it is given that AB bisects angle A. Means this angle is equal to this angle. AB bisects angle A. Show that first part, triangle ACB is congruent to triangle ADB, and second part, BC is equal to BD. So the diagram is given, the informations are given. Using the criteria for congruency, you have to prove that the triangle ACB and triangle ADB are congruent and BC is equal to BD. So in triangle ACB and triangle ADB, so we will make the two triangles separately. See, this is triangle ACB and this is triangle ADB. Okay, these are the two triangles ACB and ADB. Now see, AC is equal to AD. Reason, it is given. It is given that AC is equal to AD. It is given in the question that AC is equal to AD. Then AB is equal to AB. Reason, because they are common to both the triangles. See, AB is common to both the triangles. AB is common to both the triangles. So AB is equal to AB. And angle CAB is equal to angle DAB. AB is the bisector of, because AB is the bisector of angle A. AB is the bisector of angle A. Now you see in these two triangles, two corresponding side and the included angle are equal, so we can say that these two triangles are congruent by SAS congruency. So you write triangle ACB is congruent to triangle ADB, and the reason you write down SAS congruency, by SAS congruency. And now once it is proved that these two triangles are congruent, then we can easily say that BC is equal to BD by CPCT. So you write down BC is equal to BD by CPCT. So you can see we have proved both the parts. In the first part we have proved that the two triangles are congruent, and in the second part, as the two triangles are congruent, then we can say that BC is equal to DD. Clear? So we will move to the next question. In the next question, again they are given a diagram. ABCD is a quadrilateral in which AC and BD are the diagonals, and now they have given that AD is equal to BC. Given AD is equal to BC, they have given that AD is equal to BC, and then they have given angle DAB. Angle DAB means this angle is equal to angle CBA. CBA means this angle. It is given that angle DAB is equal to angle CBA. Now prove that first part, triangle ABD is congruent to triangle BAC. Second part, BD is equal to AC. Third part, angle ABD is equal to angle BAC. So there are three parts in this question, and we will apply the criteria, various criteria for similarity. I'm sorry, for congruency, to prove that triangle ABD and triangle BAC are congruent. So you see, in triangle ABD and triangle BAC. So first of all, you make the two triangles separately. Triangle ABD and triangle BAC, you make the two triangles separately. This is ABD and BAC. Now see, in these two triangles, we have made the two triangles separately. Triangle ABD and triangle BAC. We have made the two triangles separately. Now it is given in the question that AD is equal to BC and angle DAB is equal to angle CBA. It is given. Now you write AD is equal to BC, reason it is given. Then angle DAB is equal to angle CBA, reason it is also given. And you see AB is equal to BA because it is common. You see this AB and this BA, they are common to both the triangles, AB and BA. It is the same now, whether AB or BA, it is the same, and it is common to both the triangles. So now you see two sides, two corresponding sides are equal, and the included angle, it is also equal. So we can say that these two triangles are congruent by SAS congruency. So you write triangle ABD is congruent to triangle BAC by SAS congruency. So your first part is also proved that these two triangles are congruent by SAS congruency. Once it is proved that they are congruent, now we can say that BD is equal to AC, you know, by CPCT, and angle ABD is equal to angle BAC, means this angle will be equal to this angle, that is also by CPCT. So you can say that BD is equal to AC and angle ABD is equal to angle BAC by CPCT. We have already proved that these two triangles are congruent. So by CPCT we can say that BD is equal to AC and angle ABD is equal to angle BAC. Clear? I hope it is clear to all of you. Then we'll move to the next question. In the next question, In the next question, they have given AD and BC are perpendicular to AB and AD is equal to BC. So it is given that AD and BC are perpendicular to AB and it is given that AD is equal to BC. Now prove that CD bisects AB. Means you have to prove that O is the midpoint of AB. You have to prove that CD bisects AB, means you have to show that O is midpoint of AB. Now what we do in triangle OBC and triangle OAD. So in the diagram you can see there are two triangles, OBC and OAD. So we'll make the two triangles separately, OBC and OAD. OBC and OAD. Okay. Okay. Now you see in these two triangles, AD is equal to BC. The reason, because it is given that AD is equal to BC. Then angle CBO is equal to angle DAO is equal to 90 degrees. Okay, so they are given one side equal, AD is equal to BC, it is given that these sides are equal, and angle CBO and DAO are equal, and it is equal to 90 degrees. Although the given angle is equal to 90 degrees, but we cannot say that these two triangles are congruent by RHS congruency, because you know in RHS congruency, apart from the right angle, we need the hypotenuse equal, which is not given over there, and one more side that is given, but the hypotenuse is not given equal. So we cannot say that these two triangles are congruent by RHS congruency. Then we have to look for any other side or any other angle. So if you pay attention, you will see that angle OAD means this angle and COB are equal. What is the reason why they are equal? You are correct. They are equal because they are vertically opposite. So we can say angle COB is equal to angle DOA, and the reason you will write that they are vertically opposite. Okay, so these angles are vertically opposite, so they are equal. And now you see in these two triangles, angle side, two angles and one side, they are equal. So now we can say that these two triangles are congruent by AAS congruency, angle side. Okay, so we can say that triangle OBC is congruent to triangle OAD by AAS congruency, angle side, angle side. This angle is equal to this angle is equal to this angle, and this side is also equal. So angle side congruency, these two triangles are congruent. And once it is proved that the two triangles are congruent, we can say that OB is equal to OA by CPCT. OB is equal to OA by CPCT. OB is equal to OA by CPCT. So once it is proved that they are equal, OB is equal to OA, that means O is the midpoint of AB. That is what we have to prove in this question. O is the midpoint of AB. O is the midpoint of AB. Clear? So we'll move to the next question. Now, in this diagram, as it is very clear to you that AB is the bisector of angle QAP. AB is the bisector of angle QAP, means this angle is equal to this angle, and BQ is perpendicular to AQ, BQ is perpendicular to AQ, and BP is perpendicular to AP. Prove that first part, triangle APB is congruent to triangle AQB. Triangle APB is congruent to triangle AQB. That is the first part that you have to prove. And the second part is BP is equal to BQ. Okay. So in the first part you have to prove that triangle APB is congruent to triangle AQB, and in the second part you have to prove that BP is equal to BQ. Now what we do in triangle APB and triangle AQB. So we will make the two triangles separately. APB and triangle AQB. Okay, triangle APB and triangle AQB. Now in triangle APB, angle P is 90 degree. In triangle AQB, angle Q is 90 degree. And this angle means angle PAQ is equal to angle QAB. Now you see in these two triangles, angle BPA is equal to angle BQA is equal to 90 degree. It is given. It is given that angle BPA is equal to angle BQA is equal to 90 degree. Then angle BAP is equal to angle BAQ, as AB is the bisector, as AB is the bisector. Okay, and BA is equal to BA. BA is equal to BA means the two sides are common. BA is equal to BA. Now you see two angles, two corresponding angles and one corresponding side are equal over here. That means the two triangles are congruent by AAS congruency. So triangle APB is congruent to triangle AQB by AAS congruency, means angle side, AAS congruency. And as the two triangles are congruent, so now we can say that the other part, that is BP is equal to BQ by CPCT. Second part was BP is equal to BQ, the reason by CPCT. You see, when once we have proved that these two triangles are congruent, then we can say that BP is equal to BQ because they are the corresponding parts of the congruent triangles by CPCT. Clear? I hope now all the criteria regarding the congruence of triangle is clear to you, and I hope these examples are also clear to you. So do all the sums given in the assignment, and in the next period we will continue with the topic.